Carter, thank you so much, and thanks for inviting me here, and thanks to you and Kate and the rest of the team for organising this. I'm aware that we're running short of time, and I'm aware that it's going to be a long day with an early start, so I don't want to eat into anyone's coffee. So I may skip one or two bits, and I may talk rather quickly, but I'm aware that this is one of the most intimidatingly intelligent audiences I've probably ever presented to, so I'm trusting that you'll be able to keep up with me, however quickly I talk. I'm going to talk about the economics of climate change. I'm currently working for Cisco Systems, the idea being, as I've spoken to many of you in the fringes, the idea being here that we want to get a collaboration of key people in order to resolve this intractable global problem by bridging some of the information gaps between the disciplines, between the sectors, between different countries, in order to develop a common understanding of this problem and try and implement some solutions. The economics looks at how we might value this problem, what the solutions available might be, and how we might move towards getting a politically comprehensive deal on resolving this issue. And it is, of course, driven by the science. So it's really driven by the stuff that John and Tom have talked about this morning. And so my first chart, it's a busy chart. There's a lot going on, but it majors really on the science. The Stern Review had 5 chapters that looked through the analytical detail of the impacts on a case-by-case basis. It only really had 1 chapter that dealt with the quantitative analysis of trying to come up with a number for the impacts of climate change to compare it with a number for doing something about it. We heavily caveated the value of doing that. This is a probabilistic problem, as you will see. We know there is no forecast that can be right on this story. Coming up with a valuation relies on a number of assumptions, some of which are value judgments, and I'll talk a little bit about those. The real story is given in the details of the impacts. And this slide gives you an indication of that. It's what we affectionately call our flaming arrows slide, and you may have seen it before. And on the horizontal, it shows temperature changes relative to pre-industrial times, and it cuts the impacts across 5 dimensions. Both John and Tom have already spoken about the fact that this isn't just about warming, it's increasingly and perhaps most importantly about water, both too much and too little. The redder the arrows, the deeper the colors, the more intense and the greater the likelihood of the impacts. You'll see that one section there is green. Green is good, red is bad. You'll notice straight away that the good is overwhelmed by the bad. But there is a period with relatively small temperature changes in which temperate latitudes, mostly northern, mostly rich country latitudes, see gains as a result of this story. Longer growing seasons, a reduction in cold-related deaths being examples. But for the most part, it's a negative story, and it's an increasingly negative story as you go to the right. We've spoken about some of the impacts already, so I won't dwell on those. But 5 degrees may not sound like very much, using John's analogy of the body temperature. But 5 degrees is actually an awful lot. It's much greater on land masses, because land masses absorb heat much more quickly than the oceans, and this is a global average, and it differs regionally. 5 degrees, the last time the world was 5 degrees warmer was 50 million years ago, well before humanity was on the planet, a world, as we've seen already, characterized by crocodiles on the poles and swampy forests elsewhere. The last time the world was 5 degrees cooler was in the last ice age, when this part of the world was under massive ice sheets, and there were glaciers as far south as fringing London. So these are the kind of changes that we may see. 5 degrees, as you'll see in a minute, is something we might expect if we carry on as we are into the middle of next century. On a probabilistic basis, there's a 50-50 chance we may see something even higher than that. Now, if we had 10,000 years or 100,000 years in which to see that temperature change, then maybe the world's ecosystems and maybe humanity could adapt in time. If we're talking about a time frame of 100 to 150 years to see that change, it is simply inconceivable that we are not talking about substantial changes to the physical and human geography of the planet. Those that tell you that something of that order under business as usual, which is the basis of the IPC science, will amount to 2% of GDP, to coin a phrase used already, are probably smoking dope. It just doesn't pass the sniff test. It's got to be a greater impact than that, even before you've accounted for the uncertainties, which I'll do. So what does this mean? I mean, I don't really have time to go through the detailed impacts here, but in particular, as I say, water is a great is one of the key elements here, both too much and too little, and this makes it very much a development story. Developing countries are those countries which are at greater risk to some of these water events. They are more agriculturally based in terms of their production, so agriculture is the most sensitive source of production, and therefore their economies are more sensitive to it. And they are, of course, the least able to adapt. They are the most vulnerable because they are the poorest. But it's not just, so under most, to give you some examples, we're talking here, I've talked about 5 degrees, let's talk about 3 degrees. 3 degrees is somewhere where we might hope to stabilize if we start acting very, very quickly. 3 degrees already will probably amount to something like 1 billion extra people by the middle of this century facing water stress and a 60% rise in hunger. That's under an environment in which we begin to take the necessary action, and we do so very, very quickly. Under 3 degrees, I'm told that between 20, and then perhaps Tom can correct me on this, but by the end of the century, between 20 and 50% of the world's species might be expected to become extinct. I find that statistic staggering. We're talking here about a scenario, just to stress this again, a scenario in which the world acts and acts quickly. And then at the bottom, we're looking at some of these abrupt changes, these irreversible changes, these thresholds that we've spoken about, the melting of the ice sheets, but also these tipping points where you start to precipitate feedback mechanisms that exacerbate the problem, the release of CO2 and methane from tundra regions. Methane in particular, a very potent greenhouse gas. It accelerates the rate of global warming, which in turn will then accelerate the degree of meltback of the tundra. The depletion of the Amazon, another example. The Amazon is a major carbon sink. As the world warms, the Amazon depletes, burns away, carbon is released, the area dries out. The Amazon, under the Hadley model, pretty much disappears by the middle of this century. The melting of the ice sheets, changing the reflexivity of the planet, which also accelerates warming, and so on and so forth. So there are these tipping points, and there are these risks of some rather catastrophic events once things like the West Antarctic ice sheet or the Greenland glacier start to melt. These lubrication issues mean that these things happen rather faster, and you get these step changes. So putting this chart together, a lot of the story for the rich world, for the temperate climates, is not about the central expectation. It's about how important these risks of catastrophic events actually are. And so we tend to talk about not the center of the distribution, but the means, the tails of the tails of the distribution, the low probability, high impact events. And of course, they are very important, in particular in the longer term. We're talking about future generations. But as John and Tom already mentioned, it's not just a tail story. The mean of the distribution really does matter, and it matters in the relatively near term, in particular for developing countries. This is not tomorrow's story. We're already seeing some of the impacts in developing countries, and for a lot of developing countries, this is a story that will matter with high probability within the next 50 years. So we shouldn't get distracted only by talking about how we manage these extreme risks. And that links into the story of adaptation. Of course, as the world gets richer, in particular as poor countries get richer, their ability to adapt will increase. You can buy relatively cheap solutions to a lot of these problems, mosquito nets for malaria. But one should be mindful of the fact that adaptation does not do away with the unknown. If we don't know what it is we have to adapt to, it's very difficult to say that adaptation is going to resolve this problem. Yes, the world has to adapt, but when we don't know what risks we're facing, adaptation definitely becomes a second best, or relying on adaptation rather than mitigation is something that's very dangerous to do. And one must also be mindful that the costs of adaptation are not linear. In many cases, they are an increasing function. To take just one example, you have a certain rise in sea levels, you can beef up your levees. The sea level rises by the same amount again. You need an entire new flood defense system. The sea level rises by the same increment. Again, you have to move 10 million people. Okay, so, and you can cut this across a number of adaptive capacities. The costs of adaptation are not linear. They are increasing in scale. So adaptation, it's got to be important. It's already going to have to start, and it is indeed starting in many developing countries in particular, but mitigation has to play a key role. This chart simply takes the horizontal axis that you saw before, temperature changes relative to pre-industrial time, and looks at one aspect of the uncertainty, perhaps the key aspect, which is the temperature change. The red bars show 90% confidence intervals based on the third assessment report of the IPCC and the Hadley report, which is what we had at the time of the Stern Review. But you can think of this as very similar to the fourth assessment IPCC report, but if anything, a little bit more cautious. The grey dotted lines show you a broader range of 11 studies, which actually show a greater likelihood of some of the more extreme temperature changes for different greenhouse gas concentrations. So if anything, at the Stern Review, we took a rather cautious view on this, as we did on a number of areas, on the principle that if we can tell a compelling story on the basis of rather conservative numbers, then clearly there's a story to be told on the rather on anything slightly more damaging. So what we see here are different concentrations. We're already at about 430 parts per million CO2 equivalent, and we're going to get to 450 if we carry on as we are really within the next couple of decades. And you see that 450 gives you at least a 50-50 chance of temperatures rising above 2 degrees, this threshold which we may debate whether or not it's safe, but what seems increasingly likely is that we've delayed so long that it's going to be very difficult for us to stabilize at that level, at least not without immediate action involving significant cuts starting tomorrow, which we'll see in a minute. 550 parts per million gives you a 50-50 chance of 3 degrees, and if we carry on as we are, we're going to see 750 parts per million CO2 equivalent by the middle of next century, which pushes us out into the 5-degree plus world, a 50-50 chance of temperature changes beyond 5 degrees, which is a really, really nasty place to be. But you'll notice here the uncertainty. I can actually move around. I feel liberated. Even under this story, and this is just one element of the uncertainty, okay? This is just global mean temperatures. There's uncertainty then projected from that onto the actual impacts. There's uncertainty from the impacts onto the human vulnerabilities and potential to adapt. There's uncertainties one step back in terms of the relationship between human activities and emissions, and the relationship between emissions and greenhouse gas stocks. It's not the flows that cause the problems, it's the stocks of this stuff. These gases sit around in the atmosphere. And there's uncertainties along the whole chain of activities, of which this uncertainty is just one. And this is all about dealing with uncertainties. It's a function of the real world, and we're going to have to embrace it one way or the other. And that's one thing that a lot of the previous studies did not do, and I'll come back to that later on. So uncertainty is at the heart of this, and even on this one level, you see, look, there is a sort of 5% chance under the IPCC numbers that this thing turns out to be trivial, that we have a sort of 1 or 2 degree temperature change. There will be impacts, but they're not going to be huge, and they're going to be spread over a couple of hundred years. We can probably cope with those. However, if I were to do a sort of Al Gore and walk off over here, there's a 5% chance we're in this world of 8, 9, 10 degree temperature changes, which, to kind of coin a technical British phrase, means that we're pretty much shafted as a planet, and it really raises significant doubts as to humanity's ability and certainly ecosystems' ability to adjust to that kind of temperature change over such a short timescale. And that's just one level of uncertainty. So we're really talking here about having to cope with low probability, high impact events. So how do you go about trying to quantify this in an economic framework? Well, first of all, my first remark on that is you probably shouldn't. But if you're going to, and if people are asking you to because others have, then you may as well do as good a job as you possibly can of it. And that's what we tried to do. We were mindful of the fact that a lot of the studies that were out in the literature looked at things that were easy to measure and easy to predict. So this, if you like, is a matrix of uncertainty. It's a slightly complicated chart, but if you go down the vertical here, we're talking about things that become more and more uncertain in projecting. So at the top, you've got things like secular sea level rises, global average temperatures, relatively easy to predict. As you go down, you get precipitation events. They're much harder to predict. You don't know which areas are going to be hit when, and indeed the climate system is very nonlinear. Some of the areas which will be affected by droughts may, after a certain point, see a flip in their climate and then be affected by floods. When you look back ex post and try and we were talking about this yesterday, you try ex post to observationally account for those changes. It's very difficult to say this or that flood or this or that drought was due to climate change, especially when you've got these nonlinear effects. There isn't a counterfactual to compare it with. But we know that these kinds of increasing extremes, both in terms of floods, droughts, and other events, are likely to be a function of climate change, as John said earlier. And then at the bottom, you've got these systemic changes, these thresholds, these catastrophic risks. A lot of the studies tended to focus, quite understandably, on the bits that they could project. And equally, on the horizontal, another layer of uncertainty, you've got uncertainty in measurement. On the left-hand side, we've got market things with a market price that you can measure, things that relate to GDP, agricultural output, the cost of adaptation, and so on. As you move towards non-market factors, we're talking here about things such as the impact on human health, on the environment, and then at the right-hand side, you've got these socially contingent events. We're talking here about migration, war, and refugees. Very difficult to pin a number on those things, but they're clearly a key part of the story. when I was in the West Bengal region and I was talking in Calcutta, talking to one of the governors there about what they plan to do in a world where sea level rises push millions, maybe tens of millions of Bangladeshis across the border, he looked at me very stony-faced and said, "It's not a problem at all." I said, "What do you mean?" He said, "Well, we'll just shoot them." Now, I thought that was a bit of a poor taste joke, and then I realized it wasn't a joke at all. That really is the solution that they plan. Now, that, in a human context, is a costly solution, and it's going to be one that involves a lot of pain, suffering, and anguish, and you can multiply that across the world. It's part of the climate change story, and to ignore it is to ignore part of the story. So what did the Stern Review do? It ignored it. Why? Because pinning a number on this was just too uncertain and too open to criticism, and we'd have people stand up and say, look at the Stern Review, they cooked the books, they put a number for war in the year 2080 based on refugees and migration. What a bunch of idiots. So we didn't do that. But we tried to account for as much as we could, so we accounted for market impacts, but also the risk of catastrophic events, and we accounted as best as possible for some of these non-market impacts, including health and the environment. But even we didn't go far enough. Even we were only telling a subset of the story. But it's really important in this context to look at the fact that most of the models that were previously in the literature were really just only covered a subtotal of the true impacts. And that's not to be disparaging about those studies. It's important to start with what you can measure. But there was a lot of counting what you can measure, and we want to move the debate, if you're going to try and quantify this, towards measuring what actually counts. And that's very, very difficult to do. The earlier studies not only tended to limit themselves to things with less uncertainty, they didn't deal explicitly with our aversion to uncertainty, which is a very important part of the story. It's not just the mean expectation, it's how we ensure ourselves against the extreme risk. They used old science. A lot of the previous studies talked about 2-degree temperature changes under business as usual. 2 degrees is not a business as usual world under the latest science. And so it wasn't a surprise to us that we would come out with a larger number than the previous studies. In fact, had we come out with anything else, we would have been very, very surprised. But we still feel that there's further to go. And in fact, as I say, we didn't account for socially contingent events. The science has actually moved on since the Stern Review, so if anything, the impacts would be even larger. We assumed, as all models do, that relative prices stay the same. It's a bit of a technical point, but of course, as you get richer and as the environment becomes depleted, the value you pin on environmental resources will increase. If you account for that relative price change, there's Holt and Sterner did a very, very good review on this for at Resources for the Future, which they entitled An Even Sterner Review. And they found that you would discount the future much, much less than we did, precisely because by the time the future comes, we really would care about these issues more than we do now. So that's the D word, discounting, and I ought to say a little bit about that. In fact, I'll go back a slide before I pull that one out. One of the things you've got to do when you're trying to quantify these impacts, of course, is value future generations and value people of different incomes. If you're going to try and pin a number, it's a necessary part of the story. There was some criticism, in particular from the US, in particular from the likes of Nordhaus, that we didn't that we had a zero discount rate. Well, that's wrong on 2 counts. First of all, we didn't have a zero discount rate. Secondly, we didn't have a discount rate. Nordhaus himself makes the point, quite rightly, that you will want to account for the fact that future generations will be richer. As we pointed out in the review, the impact of a loss in consumption to a rich person is going to be a lot less than the impact of a loss of consumption to a poor person. You take $1 away from a starving street child, that's going to mean an awful lot more than you take $1 away from Bill Gates, who probably wouldn't notice. That means that it is not right, and we should account for the fact that it is not right to expect us to sacrifice resources today in order to give commensurate increases in resources to generations in the future if they're going to be that much richer. However, there's an immediate corollary to this, which should be obvious to anyone who thinks about it for more than a nanosecond. I'm not suggesting that certain illustrious economists here didn't think about it for more than a nanosecond, but it is confusing when Bill Nordhaus talks about a discount rate. If the discount rate is itself a function of how rich future generations will be, which of course it is, then the very fact that climate change has non-marginal impacts on the incomes of those future generations must mean that just as those projections have to be probabilistic, so the discount rate has to be probabilistic and endogenous to the model. And that was a key innovation that we inputted into the Stern Review. There is no one discount rate. There's a number of discount rates, each commensurate with a particular state of the world, as you would expect to be the case. We also discounted on top of that in order to account for existential risk. Why should we care about generations in the future when we may not be here? We may be hit by a meteorite. We may have blown ourselves up in nuclear Armageddon, but the people in this room and the people we know are here now, so we've got to give them a greater weight, so we did that. Indeed, we only gave us a 9 out of 10 chance of seeing our way out of this century. So that's pretty heavy discounting if you want to think of it that way. But what we then didn't do is say, okay, well, we're just going to discount on top of that purely on account of the fact that future generations are born in the future. That struck us as ethically arbitrary and very difficult to do. We weren't wackos in that respect. We had a fine pedigree of philosophers and economists backing us up on that. On the economic side, the likes of Pigou, Solow, John Maynard Keynes, even the non-economists in the room will have heard of some of those characters. Philosophers such as Amartya Sen and others all think it's pretty arbitrary and in some senses a failure of the imagination to value people's lives differently according to different dates. That's not to say that individuals don't do that in terms of our own agent-relative approach. Indeed, we care about ourselves and our families more than we do distant, abstract people in far-flung parts of the world or far-flung parts of the future. But as an objective approach to, as an objective approach to trying to adopt policies for the sake of future generations, which climate change is about, and also trying to reflect the tastes and preferences of people today, it's a very difficult thing to do. And the last thing you might want to do is look at the market to try and back out ethics. I don't know about you, but my daily consumption, savings, and investment decisions are based on a particular date, which is at the forefront of my mind when I'm planning my pension. That's the day I expect to die. I do not spend too much time thinking about what I'm going to bequeath to future generations. That does not mean that I don't care about climate change, that I don't care about future generations. You're just not going to see that in market rates, because market rates are the sum total of everybody else's decisions on saving, investment, and consumptions. So it's a strange place. It's, if I had more time, I'd tell you a sort of economist joke that I think is a great kind of analogy to this. And it ends with, those that know it will know it. It involves 3 people on a desert island, a physicist, an engineer, and an economist, and they're trying to break into a tin of beans that washes onto the shore. Well, it looks like I'm going to tell it now, doesn't it? But anyway, the physicist says, well, okay, how are we going to open this? I know we're going to put it in the sun. Thermal expansivity will break open the tin. We can eat the beans. The engineer goes, no, better way. We'll put it under a palm tree. The coconut will fall. It'll lever a pivot, and it'll flip open the lid. They turn to the economist. What would you do? The economist says, well, assuming we had a tin opener, what I would do is, trying to back out ethics from market rates, when you think about it, is about as meaningless and abstract as trying to assume that there's a tin opener when you're faced with a can of beans. You're looking in the wrong place for the wrong thing. It's a classic case of assuming something that is palpably false to assume. But if you do that, and if you come up with the kind of discounting factor that some of these people tell us we should, 4, 5, 6, 7%, then what this sort of slightly irritating chart shows is cumulative discount factors for different rates. So if you look at, for example, the blue line in the middle, that's a 2% discount rate. That means that the value of $100 today in 100 years will be approximately $10. So if you apply some of these discount rates of between 2 and 5% on the basis that that's what market interest rates tell you, then very quickly you give a weight to lives in the next generation that is less than 1/100th of the weight you give to lives today. Now, clearly, if that's your premise, you've presupposed away the problem. You've come into this as saying, look, we don't care about the future. That's what the markets tell us. So if we don't care about the future, then climate change really isn't for us. Well, you don't really need the science. You don't need John and Tom to give you that fantastic presentation. You don't even need the economics. You've pretty much presupposed away your problem. You can sit down. It's a trick that Bjorn Lomborg also plays. However, if you really want to think about whether that's how people think about future generations, you might want to ask them whether they give such a low weight to future generations. And indeed, you might want to look at even risk-free long-term market rates, which will give you a much lower number. You're looking in the wrong place, you're looking at the wrong rates, you're making the wrong assumptions, and you presuppose away the problem. That doesn't sound to us like a sensible way to proceed. But it is worth stressing these are value judgments. They do require different opinions as to how you value people of different incomes and people of different generations. And it's important that this debate is articulated. And since we published the review, we've done a lot of simulations showing a variety of different assumptions. And again, the case for action remains really robust amongst most of the plausible valuations that you can apply. Indeed, if you care for generations, if the egalitarian bit, you remember the Bill Gates versus the street child bit, if you actually become even more egalitarian, you might want to act less now because the future generations are going to be richer. But actually, there's a sort of there's a flip side to that, of course, is that you care more about some of the low probability extreme events because you become more risk averse. If you don't like people being poor, including yourself, you will take greater action in terms of insuring against the probability of some of the more catastrophic impacts. And if you run those simulations, you find in particular for high climate change sensitivities that actually becoming more egalitarian makes you so much more risk averse, you actually are more inclined to take action. You can show that in a quantitative way. I'm talking very fast. I'm conscious of the fact that we're running out of time, and I hope people people can sort of confront me and duff me up in the margins if I'm making anyone seasick. But that's the impact, if you like, and that's the attempt and all the qualifications with trying to quantify the attempt. Okay, I've got 5 minutes to do the remaining 75% of the presentation. So, okay, this requires some rethinking. Well, this is just a quick story on whether we can do this. I've talked about the fact that it's the stock of greenhouse gases that matter, not the flow, not the cumulative flows. However, economic activity correlates with the flows. So I'm now flipping to annual emissions. We currently emit around 45 gigatons of CO2 equivalent every year. That's what this chart shows. Under most projections, the blue line, which heads north, is the business as usual emissions. By the middle of the century, that will double to beyond 80 gigatons of CO2 equivalent a year. Where do we have to get to in order to stabilize? Well, think of this like any system, any stock flow system. The inflows into the stock, you can think of a reservoir or a water tank. The inflows have to equal the outflows in order to stabilize at whatever concentration, right? At whatever temperature you want to stabilize. What is the Earth's natural capacity to absorb this stuff? Well, actually, it's endogenous, but let's assume for now it's somewhere below 10 gigatons of CO2 a year. And this is the bit where people get very kind of depressed and start sort of looking glumly into their notes. We're at 45. We're going to 80, and indeed, since the Stern Review was published, the growth in India and China suggests that actually 80 is probably a great underestimate of emissions under business as usual, and we've got to get to 5. So that's the nature of the challenge, and it is a big challenge. What if we were to try and stabilize at 2 degrees with a 50-50 chance, bearing in mind the uncertainties? Well, we'd need to stabilize at 450 parts per million. We're already at 430. The increase is growing at 2 to 3 parts per million per year. To stabilize at 450, we'd have to reduce emissions down to below 10. Very, very quickly, we'd have to see emissions stabilize pretty much tomorrow, and then 6 to 10% reductions every year thereafter. Ouch, that's going to hurt. 6 to 10% reductions means scrapping perfectly working capital. It means bringing in technologies before they've matured. 450, the EU's target, whether it's safe or not, it's going to hurt. It's going to be really expensive to get to it. Had we started 10, 15 years ago, it would not have hurt, because we would have started at a much lower baseline in the stocks. But we wasted that time, and now 450 is going to be painful. What about 550? Commensurate with 3 degrees. 3 degrees, I've said already, is a pretty nasty place to be. Lots of horrible risks. 3 degrees we can do because we can actually begin the emissions reductions within the next 10, 15 years, peak within the next 15 years, but reduce emissions by 1 to 2.5% thereafter. But again, if we delay 10 years, 550 will come out of our graph. So we're already in dangerous territory, and we're wasting time. This is just a chart that I think really brings home the point. Time is of the essence. We really can't, we've wasted enough of it, and we're really, it's not a question of whether we can do this. We can do this, and we can do it cheaply. But if we carry on wasting time, we won't be able to do this cheaply. The costs increase for every month that we vacillate and delay. So what policy instruments would we want? We've spoken already. You'd want pricing. Each bit of activity at the consumer or producer level has got to take account of the price of the damage, what the economists call pricing the externality. But pricing is not enough, okay? It's important that you do this in the most efficient, cheap way, but you also need to push forward the technologies. These are going to be these are going to bring down the price in the future, and the market isn't going to do that purely through market signals on pricing. Why? Well, a lot of these technologies, the returns are in the far distant future. They're subject to a lot of risk, and they're very difficult to capture by the private sector. Indeed, a lot of the returns are social returns. So a clear case there for the states to get involved. Information barriers, and this is where this kind of the efficiency story comes in. We're all familiar with the McKinsey curves, whether we like them or not. They do tell us something about a bit below the curve where you've got all these free lunches. Economists hate free lunches. They are genetically engineered to be suspicious of them. But they exist. It's clear they exist. We know that, I know the way I run my life, that there are huge efficiencies around that I could take advantage of, but frankly, life's too short. It doesn't make for interesting dinner party conversation, so I live a wasteful life. If government can come in and do away with an efficient product, I'd be very happy. I don't go to shops with a calculator and work out the payback period of a fridge or of a light bulb. I mean, you know, I'd go insane. But I'm quite happy for standards, regulations, and mandates to get rid of that choice for me and leave me better off. In fact, I am already better off ever since I started caring about climate change. I recycle things. I turn the thermostat down. Was I born one morning miraculously as sort of, you know, as Homo economicus with an efficient life? No. It's because I care about this that actually I become better off. And that's the final point here, which is really important. It's about a shared understanding. Once you have a shared understanding of what this means, then it's much easier to elicit responsible behavior, and it's much easier to get governments to work with the grain of people's demands. Governments will ascribe to their commitments and international treaties if they feel that there is a political groundswell in those countries, and that requires a fully informed understanding at the national level, and it requires doing away with a lot of the nonsense about sunspots and uncertainty on the science. The science is pretty clear, and the story should be made as clear as possible. We need to have an informed and responsible debate about this. Okay. In terms of policy solutions, what are we talking about? Any solution's got to be effective. It's got to do what it says on the tin. It's got to deliver a world which is safe from the greatest risks of climate change. That has got to mean stabilization below at least 500 parts per million CO2 equivalent. We've said 450 is probably too high, but it's very expensive. It's got to be below 500. So any framework, unless it's outlandishly expensive, should at least aim for that. But that's the efficiency point. It should be reasonably affordable, and it should be done in a way that is most affordable. So you've got to keep this as cheap as possible. I've been told to wrap up. Okay, well, I was going to talk about the global deal as well, but I guess I've run out of time. I thought I was going to talk for a bit longer than this. What would you like me to do, Carter? What's the... Can I stretch on for another 5 minutes? Does that... Okay. I've reached capacity on how quickly I can talk. And I suspect you've certainly reached capacity on how quickly you can absorb all this stuff as well. So, but the 3 E's are important. It's got to be effective, it's got to be efficient, so the mitigation's got to be undertaken where it is cheapest. That, incidentally, is very important in terms of having a carbon market or in having a pricing mechanism that is internationally linked. What you don't want is, the Icelanders or the Norwegians or the Americans undertaking very expensive bits of mitigation, putting new kit, when across China they're building power stations which are not retrofittable with carbon capture and storage, and in parts of Latin America they're chopping down the forest. These are things which can allow for mitigation where if you're building up your capital in the fast-growing part of the world, it's much cheaper to mitigate than it is in a lot of developed countries. So it's important that there's a mechanism through global systems, through offsetting, through scaling up CDM into a wholesale or benchmark, technologically benchmark sectoral commitments, whereby you can actually pump a lot of money and a lot of technologies in some of these poorer countries, which provides them with the incentive to undertake the necessary action. So from our perspective in the rich world, we do it most efficiently, we don't waste money. From their perspective in the poorer part of the world, there's an incentive to actually start undertaking the necessary commitments and sell credits into carbon markets and make some money out of it, which eases the transition into a global policy response. And it's got to be equitable. Mitigation's got to take account of fairness. It's got to take account of the fact that what John talked about earlier, the countries that are most vulnerable to a lot of these impacts are not the ones that are responsible for putting up the stock of greenhouse gases. And that, if you're going to see traction on a global deal, has got to be acknowledged up front. And that means that developed countries have to take the lead, in particular in the short run, in terms of showing that this can be done in a way that doesn't threaten growth and can be done in a way that allows, preferably through carbon markets, for the transfer of funds and technologies across markets. What does that mean? I already said, if you remember the chart earlier on mitigation, we've got to halve, by mid-century, we've got to halve emissions from 80 gigatons, so currently from 40 gigatons or so to about 20. There'll be 9 billion people on the planet. Do the arithmetic. That means we've all got to get down to around 2 or so gigatons of CO2 a year. The US is at 20, Europe is at 10, China 5. We've got to get down to Indian levels, more or less, by 2050. That's what we've got to aim for. That means 80 or 90% cuts in rich countries. Is that outlandish? Well, actually, it may or may not be. We hope it isn't. Indeed, we argue that it is the least that is necessary. But it's also what governments have committed to under Haile-Gadam. It's also the kind of things we've seen in California. The latest US presidential candidates, France, EU, Germany, and the UK, are all talking about 80% or so cuts by 2050. That's more or less consistent with stabilization at 500 CO2 equivalent. Risks of 2 to 2.5%, 2 to 2.5 degree temperature changes. The question is, can we actually get governments to act and act early and commit to these, to actually adhere to these commitments? And that requires a number of principles which are outlined there, which I don't have time to talk about. It requires an understanding of equity, the regional differentiation, the asymmetric impacts, What happens if different countries move at different speeds? The competitiveness story, it can get overblown. It can get subjugated by vested interest. Of course, there will be losers. The important thing is to understand how big these losers are, how much they stand to lose, and in the cases where they do stand to lose, and incidentally, all the reports on competitiveness, including, and you should look at the WRI-Pedson report on leveling the playing field, show that it's a very narrow number of sectors in the US economy and in most developed countries and developing countries that are going to be hit by this, that are both carbon intensive and tradable. It's important that the debate doesn't get completely hijacked by those vested interests. But where there are concerns, and there will be some steel producers on the border of Mexico or some energy intensive sectors, that those concerns are addressed in a rational and sensible way. And I think that's something that should come out of this conference. I think I'll stop there because I've run out of time, except to just conclude very quickly that we now understand the risks from climate change. We understand the urgency and the scale. We know that we've already wasted time and there's no time to waste going forward. We know the technologies and the economic incentives for effective action are available, or where they're not, they can be created, and that this can be done very cheaply. Doesn't mean it will be done very cheaply. If this is done in an uncoordinated manner, in an untimely, expensive, piecemeal manner, it could be really expensive. We could waste resources here. If we act quickly and we apply a global response through internationally linked markets, where we work with the markets, we don't increase transaction costs, we don't add additional market failures and market distortions, this can be done very cheaply. And we're in a much better position to use our shared understanding, and it's got to be a shared understanding. Every region in the world's got to understand what this means for them and what it means for their counterparties in order to get to a negotiated solution. Then you can have a carefully designed response, and one in which developed countries take the lead. We need to take on targets, mandatory targets straight away. And we've got to show developing countries that this can be done, that it's affordable, that it can promote growth. And then developing countries, and let's be clear about this, developing countries are going to be 8 billion out of 9 billion population by the middle of this century. It's their problem. Without developing countries taking a lead on this is a lost cause. So they have to take significant action, but they can only do it once we've demonstrated in the rich world that this can be done and that it can be in their interest, and that we are taking account of the equity principles in terms of supporting those countries through technologies and financial flows. Thank you very much, and sorry for talking so quickly.